This is the board we're going to use to demonstrate the process of electrical induction. That is, making electricity appear due to the force of a magnetic field. We have two windings, a primary winding with not many turns of very thick wire, which we're going to be putting inside our secondary windings, which are coils of very fine wire, and there's a lot of them. We're going to make electricity flow into our primary windings. That's going to create a magnetic field, and the magnetic field will be exposed to the secondary windings, into which it will generate some electricity. What do we need to measure the electricity generated? Well, first of all, we need some control. So we have a switch which allows me to connect the power supply into the board via the battery to be connected up. We have a variable resistance, and moving the variable resistance will allow me to control the amount of current which is going to flow into my primary coils, the thick coils. We have an ammeter on which we can measure that current flow. The current will flow from the ammeter into the thicker windings. That will create a magnetic field. The magnetic field will expand around the secondary windings. The output of that electricity will then be fed into the voltmeter so that I can measure the amount of electricity being produced. We also have an iron core. I can add the iron core into the center of the magnet to make it more efficient. We will see that later in the process. We also have an ohmmeter, which allows me to measure the resistances of the coils so that you can have an appreciation of how much resistance is involved. So, for my primary circuit, we have a resistance of less than an ohm, 0.9 of an ohm. For my secondary circuit, we have a resistance of 95.9, 96 ohms we can call that, so it's a much higher resistance. Far longer conductors, much thinner wire is resulting in a higher resistance. So that's the layout of the apparatus. I'm now going to connect the power to the board.